This is a lesson covering 3-4 writing equations with parallel and perpendicular lines. In this lesson, you will write the equation of a line that is parallel to a given line, and you will write the equation of a line that is perpendicular to a given line. In order to do this, you will need to know how to find slope from a graph and from 2 points, and how to use point-slope form and slope-intercept form to write equations of lines. You will show that you can do this through independent practice to 85% accuracy. Parallel lines are lines that are on the same plane that will never meet. They're indicated with arrows. If you notice the red arrows here, that is telling you that the two lines are parallel. And then we know that parallel lines have the same slope. So notice here, these lines will never cross, these lines will never cross because they have the same slope. When lines are perpendicular, they intersect to form right angles. And remember, this is our symbol for perpendicular. Perpendicular lines have slopes that are negative reciprocals. And what that means is, in order to find the reciprocal, you will change the sign and flip the fraction. For instance, if this line has a slope of 2, which is 2 over 1, then the perpendicular slope would be 1 over 2, and we change the sign and make it negative. And then they will intersect at a 90-degree angle. So we're going to change the sign and take the reciprocal. And the reciprocal is just a math word for flipping the fraction. So we can tell if lines are parallel, perpendicular, or neither by looking at the slope. We look at the slope. If the slopes are the same, we look, if the signs are the same, we look to see if it has the same number. If you have the same sign with the same number, then yes, they're parallel. If you have the same sign with different numbers, they are not parallel. Now, if the signs are not the same, you have to check to see, are they opposite reciprocals? And if they are, we know the lines are perpendicular, and if they're not, we know it's neither. Let's do some examples. It says determine whether AB and CD are parallel, perpendicular, or neither. So the first thing we want to do is find the slope of AB. So using the slope formula, we will just plug in. Remember, the slope formula is y2 minus y1 over x2 minus x1. All right, so for AB, the slope will be 9 minus 6 over negative 6 plus 7. And remember, when you subtract a negative, that's why it's plus. So 9 minus 6 is 3. Negative 6 plus 7 is 1. So the slope of this line is 3. For CD, we would do negative 6 minus 3 over 3 minus 6. Negative 6 minus 3 is negative 9 over negative 3. So then we get 3 again. Both slopes are 3, so we know these two lines are parallel. For the next problem, it says it gives you points A and AB and CD. So segment AB, we're going to find the slope the same way we just did. So we're going to plug in y2, which is 2, minus y1, which is 6, over x2, which is negative 9, minus x1, which is 3. 2 minus 6 is negative 4. Negative 9 minus 3 is negative 12. So a negative divided by a negative is positive. We know that. So this would be 1/3. Okay, now let's do CD. CD, we find the slope. It is y2, which is 3, minus y1, which is 4. Make sure you're labeling these properly. If it is confusing, sometimes you might need to write it underneath x1, y1, x2, y2, just to make sure you plug in the right place. So then we have 2 minus 5 for our x2 minus x1. 3 minus 4 is negative 1. 2 minus 5 is negative 3. Negative divided by a negative is a positive, so we have 1/3 for this one as well. If both slopes are the same, then the lines are parallel. Okay, go ahead and solve example 3 and 4. Pause the video and solve, and after you've solved them, come back to see how you did. Okay, so looking at the slope of example 3, AB has a slope of -1, CD has a slope of 1. So we know that these two are opposite reciprocals, which makes them perpendicular. On the next example, AB has a slope of 1/4, CD has a slope of -4. So we know that the lines are perpendicular. 1/4 and -4 are opposite reciprocals. So the next thing we'll look at is writing equations of parallel lines. So this is very similar to what you did when you were just writing equations of lines. Now you're going to write equations of lines that are parallel to the given line. So the first step is to find the parallel slope of the line that has been given to you. So remember, parallel lines have the same slope. So we label the given point x1, y1, and the parallel slope m, and then we plug in the parallel slope and the given point in point slope form and solve for y, much like what we did in the previous lesson. So let's look at an example. The first thing we're going to do is read the problem. It says, write the equation of the line that passes through 2, 7 and is parallel to y equals -3x plus 1. Well, we know the slope of y equals -3x plus 1 is -3. So m is -3. Okay, now we're going to label our x1, y1. So 2, 7 gives us x1, y1. So we've labeled everything. Now we're going to plug it into point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. If you prefer to solve it where you plug into slope intercept form and solve for b, that's fine, but I won't give examples of that in this video. All right, so we start out with y minus 7 equals -3, because that's our given slope, times x minus 2. And we need to distribute y minus 7 equals -3x plus 6. And the last step is to add 7 to each side, and we get y equals -3x plus 13. Now let's do another example. It says, write the equation of the line that passes through -3, -1, and is parallel to 4/3 x minus 6. So our slope is right here, 4/3. We do not care about the minus 6, only the 4/3, because that is the slope that we need. So the parallel slope to 4/3 is 4/3. Then we have our -3, -1 as x1, y1. And we plug it in, y minus y1, which is -1. So we make that plus 1 equals. Our m is 4/3 times x minus -3. So that's plus 3. And so now we can distribute, so we can get rid of the parentheses. So 4/3 times x is 4/3 x, and 4/3 times 3 is 4, so plus 4. And then, so now we just need to subtract the 1 to get y by itself. So y equals 4/3 x plus 3. Now let's talk about writing equations of perpendicular lines. Okay, so we know the first thing we need is to figure out what slope we're going to use. So we'll find the perpendicular slope of the line that has been given to you. So perpendicular slopes have perpendicular lines have opposite reciprocal slopes. Remember, that means we will change the sign and flip the fraction. Okay, then we will label the given point x1, y1 and the perpendicular slope m. We'll plug in, it's the same steps as before, plug into point slope form and solve for y. So here's an example. Write the equation of a line that passes through 3, -4 and is perpendicular to y equals negative x plus 5. Okay, so the slope of this line is -1. So the perpendicular slope, that's what we're going to use. That's going to be 1 because remember we changed the sign, flip the fraction. So perpendicular slope is 1. So we'll use that for m. Then we have 3, -4, that's x1, y1. So let's plug it in, y minus -4, so plus 4 equals 1 for our perpendicular slope times x minus 3. We need to distribute, so bring down y plus 4. 1 times x is x. 1 times -3 is -3. Subtract 3 from each side. I'm sorry, not 3. Subtract 4 from each side. So we get y equals x minus 7. And that's our equation. So if we graph both of these lines, we will see that they would intersect to form a 90-degree angle. Let's do another example where we have a perpendicular slope. We're going to write the equation of the line that passes through -6, 9. I'm going to label that x1, y1, and is perpendicular to y equals 2/5 x plus 8. So here's my slope of the given line, 2/5. So the perpendicular slope, we change the sign and flip the fraction. It's going to be 5/2 and make it negative. So -5/2. So let's plug in. So using the perpendicular slope and our x1, y1, we plug in y minus 9 equals -5/2. Remember, you have to use the perpendicular slope times x plus 6. Okay, we bring down y minus 9 and distribute -5/2 x, and then -5/2 times 6 would give us -15. All right, and then the last thing we do is we add 9. So we end up with y equals 5/2, -5/2 x minus 6. And if we were to graph this line, it would be perpendicular to the original line. Okay, now we're going to look at some lines that are not already in slope-intercept form, and we're going to determine if lines are parallel, perpendicular, or neither. So this will require you to remember some skills that you learned in Algebra 1. So first, we're going to rewrite each equation so we can identify the slope. And then we'll look at the slope and determine. Okay, we're not going to do this example. We're going to do example 2, where we have 2x plus 3y equals 6. I want to isolate y, so I need to subtract 2x from both sides. I get 3y equals -2x plus 6. And I divide by 3 on both sides, and I get y equals -2/3 x plus 2. So the main goal is to isolate y So we do that by adding or subtracting the x value, and then we divide to get y by itself. All right, so this slope is 2/3, negative 2/3. Now let's find the slope of the other line. Okay, the other line is 6x minus 4y equals 24. First thing I want to do is subtract 6x. That leaves me with negative 4y equals negative 6x plus 24. Okay, and then the next thing I want to do is divide by negative 4 on both sides. Always leave your numbers as a fraction if they don't divide evenly. So negative 6 divided by negative 4, it doesn't divide evenly. So we simplify the fraction and write it as a fraction. So negative divided by a negative gives me a positive. 6 over 4 simplifies to 3/2 x. And then 24 divided by negative 4 is minus 6. But we don't care about the y-intercepts, we care about the slope. So I have this slope, have this slope. When I compare them, they're not the same, but they are opposite reciprocals, so I know these two lines are perpendicular. All right, now we're going to do the next example. I want you to pause the video and work these problems yourself. Rewrite the equation, then unpause it and look to see how you did. Okay, so take a look. In the first equation, we wanted to isolate y, so we subtracted 2x from each side, then divided by 5, and we wrote our slope as a fraction, so we got y equals negative 2/5 x minus 5. On the second equation, the only thing we needed to do to isolate y was to divide by 10. So if we divide by 10 on both sides and simplify, we also get negative 2/5 as our slope. These two slopes are the same, which means the two lines are parallel. Okay, good. Now let's take it a step further. It says the line that passes through negative 8, 6, and is parallel to the line 4x plus y equals negative 5. We're going to write the slope-intercept form. Okay, so the first thing we want to do is label our x1, y1. And we also want to find our m, because whatever the slope of this line is, it's going to be the same for the new line we're creating. So over here, I'm just going to isolate y. 4x plus y equals negative 5. We're going to subtract 4x. We get y equals negative 4x minus 5. And that's all we need to do because y doesn't have a coefficient. So we look to see what is the slope. It is negative 4. So that means we're going to use negative 4 for our slope. And then we're going to use negative 8, 6 for our x1, y1. So let's plug in y minus 6 equals negative 4 times x plus 8. All right, so we now need to distribute negative 4x minus 32, and we add 6 to each side. We get y equals negative 4x minus 26. And that's our equation. And notice it has the same slope as the original one, but a different y-intercept. The last example we're going to look at says, write the slope-intercept form of the line described. We're writing the line that passes through negative 3, negative 4, that's our x1, y1, and is perpendicular to the line y equals 2x minus 3. So this is our slope, 2. So the perpendicular slope to 2 is, change the sign, flip the fraction, 2 over 1, it now becomes negative 1/2. So we're using -1/2 for our slope and -3, -4 for our point. So we plug into point slope form. Y minus -1, that's plus, no, y minus y1, which would give us y plus 4, equals, we use our perpendicular slope, -1/2 times x plus 3. Okay, and now we just want to distribute, so y plus 4 equals -1/2 x minus 3/2. Notice how I'm leaving this as a fraction. It's just better to keep a fraction. You don't have to worry about rounding, and it's just easier to deal with. And remember, on your calculator, you can use alpha y equals to perform operations with fractions. All right, the next thing we're going to do is subtract 4. So if I want to subtract 4 from 3/2, I get y equals -1/2 x. Now, minus 4, I need to convert that so that I have a denominator of 2. So minus 4 becomes -8/2. Now I can combine them. -3 minus 8 minus -3/2 minus 8/2 gives us -11/2. Okay, and we have a nice little neat fraction. And that concludes the examples for this lesson. So after watching this lesson, you should now know how to write the equation of a line that is parallel to a given line and how to write the equation of a line that is perpendicular to a given line. And hopefully you now know how to identify slopes that are parallel, slopes that are perpendicular, or slopes that are neither. Thank you for watching this video.